temperature sensor overall, okay, in the car. Now this could be coolant temperature sensor, right? Cylinder head temperature sensor, transmission fluid temperature sensor, engine oil temperature sensor. It could be AC air conditioning temperature sensors like evaporator temperature sensors. It could be outside air temperature sensor. It could be cabin temperature sensor for hatchback, air conditioning system. It could be your fuel temperature sensor. It could be your fuel tank temperature sensor. The main one, obviously for engine management, is your air temperature sensor, intake air temperature sensor. Sometimes they are on the intake air filter area, air filter housing area. Sometimes if it's a turbocharged engine, it could be the charge air temperature sensor that's actually in the intercooler piping somewhere around the manifold or before the manifold. So there are a lot of different temperature sensors they use in automotive these days, right? Now there are a couple of different types of temperature sensor over the years. Obviously we've seen in automotive you could have a one-wire temperature sensor. They used to use that in back in the days for the fuel gauge, the temperature gauge in the dashboard. So let's say this is your dashboard, right? And you'll have a gauge, right? Hot and cold gauge, right? And then they will have one wire coming out of there, and it will go to your temperature sensor. All right, and the temperature sensor will screw into the head, okay, engine head, or sometimes on the thermostat housing. Okay, they used to have this type of temperature sensor, but this type of temperature sensors are going away. They don't really use this in automotive anymore. Usually they work with communication, so one sensor will obviously detect the engine temperature sensor, and the engine computer will share that information with the dashboard instrumental cluster, and that's how it works. So this type of sensor is going away, so I'm not even gonna bother talking about it. They're pretty simple design. Now there are other variables there. You might sometimes find there will be like a 3-wire temperature sensor. They will have 2 temperature sensors on the same sensor, you know what I'm saying? So you could see 3 wires coming out of the sensor. Okay, that's obviously going to be a variables, but most of the time all these sensors I just talked about with you, from coolant temperature sensor to transmission fluid temperature sensor, pretty much overall universally they all work the same. Okay, so I'm going to show you how you can diagnose this type of cars. Obviously we will get into some basics of it, how it works and all that. But my focus here again, like always, is to get to the diagnostic, get to the result as soon, as quickly, and as efficiently as possible. That's always my target when I'm teaching this sort of stuff, guys. Okay, now temperature sensors, like I said again, doesn't matter what temperature sensor, what system, they're always gonna have 2 wires. Okay, usually, okay, 2 wires comes from the control module. Okay, now the control module could be engine control module. If it's a coolant temperature sensor, more than likely it's coming from the engine control module. If it's a transmission fluid temperature sensor, more than likely it's going to come from the TCM, transmission control module, right? If it's a cabin temperature sensor, more than likely it's going to be a HVAC, your air conditioning air conditioning control module. So there's obviously the control module could be anything, okay, but let's just say today this is our coolant temperature sensor we're going to talk about, but the principles, how they work, testing procedure, they're all going to be same for any temperature sensor they use in automotive. Okay, so for that reason, let's draw, let's say this is your control unit. Okay, this is your ECU. All right, right here. So what's going to happen? ECU is going to have two wires coming out of it. Okay, so let's draw one wire, and you're going to have a sensor here. Okay, let's just do that. Sensor. So this is your temperature sensor, right? TMP temp. Now it's going to come in to the sensor. Now you're going to have another wire coming out of the control module as well. Same thing, same principle. So let's draw another one right here. So this is the basic. When you look at the wiring diagram, when you look at the service information, this is what you're going to see typically. Okay, so what you're going to have is you're going to have a 5 volt on the one wire, and you're going to have earth, okay, negative on the other wire. That's how it's worked. But if I just give you information, that's it, like the wiring diagram will show you, it doesn't usually make sense if you already didn't know all this stuff. It doesn't make sense. So I need to draw what's inside the ECU, so you'll get a bit of a grasp on how the system works, and you can understand where this 5 volts coming from, where the earth coming from. Okay, now let's talk about this ground wire. Okay, the earth wire, what's going to happen inside the ECU? It's going to ground it. It's going to come from the inside the ground. Okay, this is a negative source. Okay, now that's pretty simple. On the red wire here, the 5 volt wire, okay, we call it, let's say we call it a reference voltage, right? What's going to happen is it's going to go in, right, through a resistor, okay, and then it's going to have a 5 volt source in there, okay, some kind of regulator, a 5 volt source inside the ECU. Now inside the sensor, okay, I'll just draw this a little bit big. All right, so inside the sensor, let's say this is your sensor, okay. What's going to happen is inside the sensor you're going to have a resistor, okay, a variable resistor. So usually when you see a line going across the resistor, that's a variable resistor. They can change its resistance value. Okay, that's what it means. So that's how it's going to be working. Okay, that's the circuit design. All right. Now, also inside the computer, what you're going to have is, let me just draw this a little bit better, so we'll have a bit more space here. So I'll just draw that a little bit better. Okay, so this earth gonna come in. It's gonna go to the earth, right? Negative source. Now, inside the computer, what you're gonna have is a sensing device, okay? I don't know what it is, I don't know how they do it, I don't really care the engineering behind it, okay? But just remember guys, there's a sensing circuit inside the computer. That's where it's gonna read the voltage at all time, okay? So let's think of it as a multimeter, a digital voltmeter, okay? It's gonna have a voltmeter in there watching that leg, that circuit, voltage at all time. That's how the computer knows what the voltages are doing, okay, at the sensor. And sensor's not gonna tell the computer, hey, okay, I am at 20 degrees Celsius or I'm at 100 degrees Celsius. Sensor's not gonna tell the computer that. Sensor's gonna only show the voltage reading, and computer is going to convert that voltage reading into a temperature reading, depending on how the engineers wrote the software, programming in the issue, okay? So this sensing circuit is gonna always watch the voltage in the circuit, right? Whatever a computer sees right here, That's what you're gonna see on the scan tool as well. Okay, if sometimes on the scan tool you'll have a voltage reading, like on the live data, as well as you can have the temperature reading, as in degree Celsius, degree Fahrenheit, okay, whatever the units you're using. So if the computer is seeing 3 volt here, you're gonna see 3 volts on the scan tool. And the temperature reading you're seeing on the scan tool, together with the voltage reading, that's the ECU has processed that data and convert that into a temperature reading. Okay, guys? All right, so basically 5 volts gonna come through, travel through the resistor inside the computer. This is inside the computer, guys, and it's gonna travel all the way to the sensor, okay? And sensor's resistor, this is going to vary, okay? This is going to change with the temperature. So according to the change in the resistance, okay, computer gonna see different voltages there, okay? And then it's gonna find a path back to the earth, all right? Now, usually, this is what I see, usually on cars, so this is a 0 to 5 volt sensor, okay, because we got the 5 volt reference voltage, so it's gonna be 0 to 5 volt data here, reading. So I have seen on cars, 5 volt means, I think it's like 280 degrees Celsius, something like that. I could be wrong a little bit there, guys, but it's gonna be up there, 200 plus degrees Celsius. And 0 volt equals, sorry, I'm wrong here. Try again. Okay, 5 volt means it's at minus 40 degree, okay? And 0 volt means it's positive 280 degree, okay? That's the temperature. That's how I have seen on multiple computers. That's how the reading works, okay? Now, if you see, let's say you got a fault code, coolant temperature circuit malfunction, or circuit too high or circuit too low, whatever the fault code description you got, right? And you look at the live data, and if you saw minus 40 degree means, what does that mean is computer is seeing 5 volt in the sensing circuit. If you see positive 280 degree, that means computer is seeing 0 volt in that sensing circuit. That's what it means, okay? Now, to really make you guys understand, I'm gonna have to go to the basic here, okay? You would have a question, why do they have a resistor here inside the car? This is inside the computer. This is a fixed value resistor, okay? I don't know the value of that resistor. Okay, I'm pretty sure, I believe that the value of that resistor is gonna be different to different cars, okay? I don't know what the value of that resistor, and I don't care. And you would probably ask, why do they have a resistor inside? Because if there's no resistor in there, the computer cannot read the changes of voltages, okay? For that reason, I'm gonna have to take it to a basics, okay? If you guys already know, that's good. If you don't know, just hear me out. Okay, down here, I'll just make another circuit. So you got a 12 volt, let's say 12 volt circuit, right? So you got a battery positive and you got a battery negative, right? So let's draw a circuit, okay? So you have a resistor here, and go back to the battery negative. Now, look at this sensing circuit. Where is that located? Okay? Now, if there was no resistor here, let's get this resistor out of the way. If there is no resistor here, comes straight from the 5 volt power supply, right? what are you gonna see on this sensing circuit at all time? You're gonna see 5 volt at all time, because 5 volts gonna go in there. It's gonna, the meter, the sensing circuit is gonna read 5 volt. It's just like a voltmeter, like I said, and it's gonna find a path to ground. You're gonna see 5 volt at all time. Does it matter? Well, it could matter, but in a let's say practical sense, does it matter what the register are doing here? If the register value goes up or down, does it gonna make any difference to what the computer is seeing at that sensing circuit? No, it's not gonna change nothing, because it's like you're putting a multimeter right on the battery post, positive and negative. That's where you're putting your voltmeter. Does it matter what happens to this register? No, because you're going to see 12 volt at all times. So the voltmeter is never going to see the voltage changes, right? So computer cannot tell what the temperatures doing, what the temperature changes are. So for that reason, what they did is they put an extra resistor here on the circuit. This is on series circuit, right? And what they've done, according to the ECU circuitry here, right? So we got a resistor right here. So what they've done with according to that is they taking a measurement from in between two resistors, okay? One resistor here, one resistor there. They're taking a measurement between two resistors. So basically, according to that, if I have to make my voltmeter connection here, I would say that's my voltmeter, right? That. So one leg is going to the earth, right? And other leg is going between two resistors, between that resistor and that resistor. Now, if you know voltage drop, okay, whatever the value of the resistor here and here, according to the value of the resistor, this right here where you're measuring, the voltage right here going to change with the resistor change in resistance. Do you understand what I'm saying? Because let's say 12 volts going to come down, it's going to go through the resistor, and that resistor is going to drop that voltage. So, and when you measure the voltage right here, you're going to see that voltage change. So let's say the coolant temperature is very cold. The engine is cold. So let's say the resistor here going to have some value, right? So let's say you are seeing, when the car is cold, let's say you are seeing 12 volt here, whatever the case, right? And once the car warms up, this resistor value is going to change. So what's that's going to do? It's going to drop voltage, right? And you're going to see the change right here. Okay, I'm just giving you an example here. So without two resistors, you're not going to see a voltage change. You can go back and learn some Ohm's law, how the circuitry works, all the basic stuff. You can go and do that homework, right? There's plenty of resources on the internet you can read through and get familiarized with. But this is my point, all right? So basically the exactly same principles they applied in the circuitry. Okay, that's why every time the resistor changes here, you're going to see a change in that sensing circuit. Okay, if there is no resistor, if this sensing circuit is not in between the two resistors, that sensing circuit is not going to see the changes in voltage. Okay, now we understand the basics principles, what's happening inside the ECU, right, and what's happening inside the sensor. It makes it very easy to diagnose this sort of problem. A lot of the time it's very simple circuit. Okay, you can diagnose this sort of stuff within 5-10 minutes most of the time. Obviously there's going to be complications there sometimes, a little bit difficult problems. It depends on the problems, how far, how much of an extent you have to go to. But if it's a simple you know, coolant temperature sensor diagnostic is very, very simple, right? Now, let's say the car come in, right? And there's a coolant temperature sensor circuit fault, okay? There's a difference in performance fault and a circuit fault. So usually you'll have a description on the fault code on a scan tool, like coolant temperature circuit, high, low, whatever the case is. That's your circuit fault. Sometimes you'll have a coolant temperature sensor out of range, or, you know, performance problem. You'll have a description like that. So that would be a little bit complicated diagnostic, but usually if it's a circuit fault, you know the fault is happening right there and there, unless it's an intermittent problem, right? But if it's a hard fault, as soon as you clear the fault code comes back on straight away. Usually that's a circuit fault, hard fault. They are very easy to diagnose. Now let's say you got a circuit fault, okay, to coolant temperature sensor circuit fault. Okay, doesn't matter if it's a coolant temperature, any temperature sensors, you know, doesn't matter what you're doing. For this example, we're gonna look at the coolant temperature sensor. So you got a coolant temperature sensor fault, and you look at the scan tool, right? Let's say this is your scan tool, right? On a scan tool, right, you got a circuit fault. Now you go to live data on the scan tool, find the coolant temperature sensor, you know, let's put ECT, engine coolant temperature, okay, ECT. All right, now you're going to have, sometimes you'll find two values, voltage values and a temperature value. Sometimes you'll only find one or another, okay? So let's say this car has both the values. So let's say the voltage is at 5 volt and coolant temperature is sitting at minus 40 degree. Okay, that's what you see on live data, right? Now, to really diagnose this car, it's very simple. So 5 volt on the scan tool means the computer is seeing what? 5 volts right on the sensing circuit. It's saying 5 volt. That's what you see on the live data, right? So if you see a 5 volt, okay, more than likely the problem is it's an open, okay? It's an open circuit. So computer scan tool might even tell you temperature sensor open circuit, something like that on the description, on the fault code, okay? So why is it an open circuit? Means, okay, if you disconnect this wire, let's say you disconnect this wire plug from the temperature sensor. You got two wire, like I said, one's gonna have 5 volt come in and one's gonna have earth, right? So if you disconnect this sensor, what are you gonna see here? You're gonna see 5 volt, because 5 volts gonna come in. So you're gonna have 5 volt through the resistor to your voltmeter and all the way until the connector. You're gonna have 5 volt. Let's say if the wiring is intact, nothing wrong with the wiring, right? You're gonna see 5 volt because there is no path to ground, so there's no voltage drop. Okay, so you're gonna see 5 volt right across. That's what the sensing circuit is gonna see, 5 volt. That's what you're seeing on the live data, 5 volt. You already know it's an open circuit, right? Let's say you got on the scan tool, you got 0 volt and temperature is sitting at positive 280 degree, something like that. Okay, I could be wrong on that value, but it's going to be more than 200, like I said. So what does that mean is computer is seeing on this circuit 0 volt. So where does the 0 volts going to come in there? If the 5 volt is shorted to ground. So let's go from here to here. If you short this to ground, we got the ground here, we had the 5 volt coming in here, right? If you short that to ground, what are you going to see? All that 5 volts going to drop to 0, okay, across that resistor, okay? Now, it's safe to short the computer 5 volt to ground. when it comes to temperature sensors, because they have this resistor inside the circuit, that's a buffer for you, okay? You're not going to hurt the computer. If it's a potentiometer, 3-wire sensors, potentiometer, or I'll just draw it here. If you got a 3-wire sensor, 3 wires going to come in, right? One going to have 5 volt, one's going to be your signal, right? And one going to be your earth. This is your potentiometer circuit, okay? So what's going to happen inside the computer, okay? Inside the computer, you're going to have earth for the earth. Signals going to go to your voltmeter like that. That's where computer is going to check the signal, right? And this 5 volts, 5 volt is going to come directly from 5 volt source inside the computer. So if you short that to earth, right, there's a danger that you're going to harm the computer. Not that I've seen it before. I have accidentally short 5 volts multiple times. I've never damaged the computer so far, God forbid, right? But they have some kind of protection to save the computer. But not all computers are going to have that safety, okay? Not all computers are going to have a programming or hardware in there to protect the computer from accidental damage. So it's best not to do that, okay? If you're testing the circuit and all that, best not to do that, obviously, right? So on this example, I'm just trying to show you, because it comes directly from the source, it's always best practice not to short it to ground for any reason, okay? If it's shorted to ground in the wiring harness, in the sensor or whatever, it's going to pull all the 5 volts to ground, not only for that circuit, but for other circuits too, because a lot of the time computer will share that 5 volt to multiple different sensors that needs 5 volt. And all the sensors are going to have 0 volt because there's a short somewhere in the wiring harness or the circuit on the sensor, whatever. Now you're going to have multiple faults, multiple sensors not operating, okay? That's a different scenario. We can talk about it on a potentiometer class later. I'm just trying to show you why we can short this temperature sensor circuit to ground and there's no problem whatsoever because of the resistor they have inside the computer after the 5 volt. That's like a buffer for you, okay? They'll protect the computer from damaging, okay? Now, you saw 0 volt. Plus 280 degree in the computer, that means this is shorted, okay? The circuit is shorted, computer is seeing 0 volt, that's what you're seeing on the scan tool, all right? Now, how do you know where the short is? Let's say you got 0 volt on the scan tool, like that. There's a fault on the computer saying coolant temperature circuit low, okay? Low means 0 volt. Circuit high means 5 volt. Okay, let's interpret it that way. Most of the time, that's how they interpret in the description in the scan tool. So how do you know where the short is? It could be computer, bad computer. It could be wiring. It could be sensor. Let's say you got a fault code like that. All you have to do is, guys, what's the scan tool, right? What's the scan tool? Disconnect the wiring from the sensor. Disconnect that plug from the sensor. As soon as you disconnect, what's going to happen? Computer is going to read what here? 5 volt. And if this jumps to 5 volt and our temperature goes to minus 40 degree, as soon as you disconnect that plug, what does that tell you, guys? That will tell you the wiring is good. The computer is good. There's no short in the wiring. Let's say if you have a short in the wiring like that, or the 5 volt is touching the body, the engine, chassis, whatever, okay? What's going to happen if you disconnect this? Nothing's going to change here because this is still going to read 0 volt if that's the case. Because ground's going to travel, it's going to pull all that 5 volt through the resistor. Okay, you're going to see 0 volt, that's what you're going to see on the scan tool, 0 volt, nothing will change. If that's the case, you're going to have to start changing this way, changing the wiring of the computer. Okay, now, if, let's say, the first scenario, if the voltage As soon as you disconnect the plug, if the voltage rises, temperature change to minus 40 degrees Celsius. What does that tell you? Wiring is good, computer is good, you're done with your diagnostic. The problem is the sensor. Change the sensor, you're done. Right? The another scenario, let's say this is shorted to ground. Or you can say if it's shorted here, whatever the case. Okay? If you disconnect the plug, nothing's going to change, like I said. Now, where is the problem? Is the computer problem? Is it the wiring problem? Now, you're going to have to pull up a wiring diagram. Up until that point, you don't need a wiring diagram. You don't need any information up until that point. Now, nothing changed. Okay, it's still the scan tool still sitting at 0 volt. Okay, you're still seeing 0 volt even after you disconnected the wire. Okay, there's a short in the wiring harness, or there's a problem in the computer. Now, how can you diagnose this? The quick and easiest way I find is go to the computer, find the wiring diagram, look at the pin, which pins are 2 wires for my coolant temperature sensor. Go to the computer, find the wires, right? Now at the computer, okay, I would say cut this wire at the computer, just near the computer, cut that wire and check the voltage here. Check the voltage right here with your voltmeter, multimeter, right to the ground obviously. As soon as you cut that wire, did that jump to 5 volt? Sorry, yes, did that jump to 5 volt? And on the scan tool, did that jump to 5 volt? As soon as you cut the wire, if they jump to 5 volt, means there's a problem in the wiring between here and here. Probably nothing wrong with the sensor, and we have confirmed there's nothing wrong with the computer. Computer is sending 5 volt out the way it should, right? If that's the case, you're going to have to start chasing the wiring short. Somewhere there's a short in the wiring, okay? Now, let's clear all that. Now that's one scenario. Second scenario, the ECU, like the live data is stuck at 5 volt at all time. Okay, minus 5 volt is minus 40 degree. Okay, it's stuck at 5 volt at all time, right? Right, you disconnect the wire, right? Nothing changed, right? There could be a possibility that you got a break in this wire on the earth circuit. There could be a break. Okay, you could have a problem inside the computer, right? There could be a break. This circuit could be burnt inside the computer. Let's say for this example, right, we got a break in the earth wire, right? Does it matter? Right, even if you disconnected or connected, it's not going to change anything for you because there's no path to ground. So there's going to be no voltage drop. So 5 volts going to travel through the resistor all the way. Let's say the sensor is intact, nothing wrong with the sensor, right? It's going to try to find a path to ground. What happened? There's a break right here, right? It's never going to see a voltage change. On the sensing circuit means on the scan tool you're going to see 5 volt at all time. So what do? In that case, whenever you're disconnecting the sensor and checking the temperature sensor, when you disconnect this wire, put your multimeter, put your voltmeter, check if there's a 5 volt present here, right? If the 5 volt present, with it disconnected, what does that mean? Everything on this 5 volt circuit wire computer is good, right? Now put your test light, right, and look for earth. You know, I'll just grab a test light quickly. All right, guys, I got a battery here to demonstrate. So if that's the case, right, get a test light on the battery positive here, right? Put your test light on the battery positive here, like that, and trying to find the earth right here. Put your test light right here. Do you see earth? Does the test light light up? If the test light light up, that means this circuit is intact all the way to the computer. There's nothing wrong. Only thing is left is the sensor could be at fault. Change the sensor, you're done. Let's say you put your test light to battery positive and trying to find the earth right here. The test light didn't light up. What that means? The earth is missing. So what do? Same thing. Go to the computer, find the pin. Which pin is it? Which wire is it? Check battery positive, test light. Check earth right there. Does test light light up? Yes. So what does that mean? The problem is this wire. There's a break somewhere in that wiring. If you don't see the earth right here, right? If you can't, the test light doesn't light up. What does that mean? Your computer is bad. That circuit in the computer is bad. So that no matter how many times you put a new sensor in that car, it will never work, right? Okay, the other thing you can do here is, guys, once you disconnect, once you find out if the 5 volt is present there, the earth is present there, okay, you also need to sometimes verify if your sensing circuit is good, okay? You could still have 5 volt coming in, you could still have earth coming into the sensor. Sensor could be good, but the scan tool is not reacting. There's no temperature changes there, okay? With the obviously coolant temperature, as the engine warms up, you need to see some kind of voltage changing, temperature changing, right? You didn't see nothing like that. You verify there's a 5 volt, you verify there's earth, the sensor is good, you already changed the sensor, right? Sometimes you could have a problem with the sensing circuit. Okay, even everything is intact, the sensing circuit is not reading true. There's something wrong in that circuit, in that hardware or in there, okay? So for that reason, we can always do a bypass test. We can manually make the computer react, okay? So basically for that one, what you're gonna need is a resistor, okay? Okay, the resistor can be anything, okay? You can always buy different varieties of resistor. I got a resistance box here, okay? Now he's got a few different dials here. You can change the resistance, whatever you like. Now, don't care what resistor do you need for what temperature. That's not really my focus here. All my focus is, can I change my voltage reading at the sensing circuit, meaning on the scan tool, using external resistor. So I'll just put it down here, right? So what I'm going to do is I'm going to disconnect the sensor, put this, okay, put this resistor between the two wire like that, short it out, right, pretty much, and then start changing the resistor on the wheel. Start changing resistor and you'll see the changes in the scan tool. If the computer, if this live data is reading, 80 degree, 60 degree, 3 volt, 2 volt, 2.5 volt, changes with the resistance changes, right? That means we know that computer sensing circuit is good, right? Because we can see that on the live data, okay? If that's the case, more than likely the problem is what? We are checking at the connector on the coolant temperature sensor. The problem is the coolant temperature sensor, guys, okay? Now, if you don't have a resistor wheel, you can always short it out. Just get a jumper lead, like just straight wire, and jump this 2 pin at the connector. So what you're basically doing is, you're pulling that 5 volt to earth. So you're giving a direct path to earth. So now, let's say your scan tool is stuck at 5 volt, right? As soon as you jump these 2 wires, what's the sensing circuit gonna see? 0 volt. What's the live data is gonna do? It's gonna jump to 0 volt, and this is gonna jump to positive 280 degree, right? There's few bypass tests you can do here, guys, okay? Now, I just wanna talk about a story quickly. I had a car, Mazda Tribute, back in the day. This is many years ago. Okay, this car had problem with hunting, so we call it hunting, as in the revs will go up and down, humming like like that. Revs will climb from 800 to 1600, come back 800, 1600. It was humming, but it would only happen when it's dead cold in the morning. With the first start in the morning, for about 30 seconds you will hunt like that, and then it will disappear all day, no problem, and next morning same thing. So this car has been to multiple mechanics back then, and then nobody can sort it out because you only got that 30-second window, right? 30-second window to check, to do your checks, and after that you can't do nothing all day, and you have to wait till the next day. So it got multiple different parts, new ignition coils, spark plugs, trying to fix that problem, guys, right? So at the end I got the car, right? And the first day I tried to sort it out, it did the same thing to me. 30 seconds, I can't do nothing. I waited till the next day, right? This is a little bit of story time, guys, but there's a lesson on it, okay, on this story. So what I did next day, I went to the coolant temperature sensor, disconnect the sensor, right? And I put resistor like that in that 2-wire. I put a resistor like that, and I was playing with the resistor, right? And I made it like cold. I made it like 10 degree, I think 20 degree on the scan tool. As I was playing with the resistor, I was looking at the scan tool, and when I got that cold degree Celsius, whatever that was, 10, 12 degree, whatever I put back then, I left the resistor like that, and then I started the car, and then guess what? It was hunting the whole time. Okay, it was hunting the whole time. It gave me plenty of time to do my check, find the reason why it was doing. At the end, the problem was a vacuum leak in the intake manifold. The rubber, the gasket on the intake manifold was bad, so it would hunt like that just in the morning. And then, you know, so far as I know, this is my understanding. When it's really cold, obviously the oxygen sensor is not functioning. Obviously, it's not trying to correct the fuel trim, right? Second, maybe the engine was trying to see a little bit of temperature rise before they start correcting the fuel mixture. So as soon as it heats up a little bit, 30 seconds, 1 minute, oxygen sensor is hot, you know, coolant temperatures start climbing up. As soon as it happens, the computer was correcting that extra vacuum leak, extra air going into the engine, so you will hear no more hunting like that. So when I did that, computer decided, okay, now engine is cold, I'm not gonna correct the fuel trim. Maybe that's what happened. This is my understanding from that. But see, if you know all this bypass testing and all that, you can use it to your benefit to sometimes diagnose vehicles like that as well. So that's just a little story I wanted to throw out there, so you guys know there's other function, practicality of a resistor wheel. You know, if you know the bypass test on the cooling system, coolant temperature sensor circuit, you can do a lot of other things with that as well. Okay, all right, that's just the basic of it. Maybe let's go to the car and let's do a real practical testing. And all right, guys, let's do some practical on the car here. This is a Toyota Hilux 2007 model, and we got our temperature sensor right here. That's our temperature sensor. Okay, guys, now it doesn't matter what type of temperature sensor, what car, they're all gonna work the same. And this one has 2 wires. Okay, if you can see that or not, there's 2 wires in that sensor. Now this one's sitting right on the head, I would say, engine head, right? So first thing we're gonna do is we're gonna go to the scan tool, right? And right now I got no trouble codes. There's no trouble codes whatsoever. There's nothing wrong with the car. This is just to show you guys. Okay, guys, now if I unplug this wire, okay, I'll just go reach down there and unplug this wire, right? Unplug that wire from the coolant temperature sensor. Now let's read the fault codes. Coolant temperature circuit input high. So what does that mean? Is the computer is reading 5 volt, the highest voltage on this circuit, right? 5 volts. Why? Like we explained to you earlier on the board. It's reading high because we disconnect the sensor right here, right? So what's the sensing circuit's reading at the moment? It's reading 5 volt at the moment. That's why the fault code says, the temperature sensor, temperature circuit input is high, right? So if you go to live data, in this case, and if you go down to coolant temperature sensor, like I explained to you, it's showing me minus 40 degrees Celsius. That means it's high. Unfortunately, this live data on this car is not giving me the voltage reading. It's only giving me the temperature reading. We can always try the OBD2. Maybe let's go back and try the OBD2. We can do that. Okay. We can always come back if there's no lock there for us. Let's go try OBD2. Let's see what OBD2 has to give us. All right, we'll just go auto scan. It's a very slow communication on this vehicle for some reason. I just wanted to show you that voltage reading on the scan tool. It's not necessary. We already know it's minus 40 degree means it's high voltage. It's 5 volt. All right, it's unable to communicate for some reason, guys. So we just go back to the way we had it. But you guys got the idea. 5 volt means minus 40 degree. Okay, guys. Not all computers gonna give you that voltage reading. Not all cars gonna give you that voltage reading. Sometimes you're only gonna have temperature. Okay, so we're just gonna have to work with it. Okay, so let's go back to history and we go to our Hilux. All right, I'm only interested in engine control module. All right, let's go back to the trouble codes, right? Engine circuit input high. Now, that means the computer is reading 5 volt, right? Now, that 5 volt computer that's reading, because we disconnect the sensor, computer is reading 5 volt. But, let's say if there is a problem with the sensor, like if it's connected, let's say we didn't disconnect it, you got a break inside the sensor. Isn't that gonna give you exactly same thing? Because this 5 volt's gonna, there's gonna be 5 volt on that sensing circuit because there's no earth to drop the voltage, right? That's one scenario. You could have a break here on the wiring, right? You could have a break right here on the wiring. The computer's still gonna see 5 volt, high voltage input, right? You could have a break in the earth. Computer's gonna still see what? 5 volt, because 5 volt's gonna travel through the resistor. There's no path to ground, right? Computer's still gonna see 5 volt, right? Now, in that case, what you can do, you can disconnect the sensor, right? And you can check if there's a 5 volt coming in and earth coming in or not. If there's a 5 volt and earth coming in, but the fault code is showing input high, right? We got a fault code for coolant temperature sensor. More than likely, the problem is the temperature sensor. Okay? Now, if you didn't see the 5 volt and earth, more than likely you're gonna chase the wiring and the computer. That way, you gotta do your checks. Okay? What are you missing? 5 volt or are you missing earth? If you're missing 5 volt, go that route. if you're missing earth, go that route on that earth circuit, right? Now I'm going to do a couple of checks at the plug quickly. All right, I'm going to grab my multimeter. Put the multimeter on volt setting, right? Because we're checking for voltage. We're going to look for that 5 volt. Obviously, the ignition key has to be on. So I'm going to put one lead to the battery negative. Okay, so I'll just find a body ground here, doesn't matter where. And the other lead of the multimeter, I'm going to go to that plug and I'm going to look for 5 volt. At this stage, I don't know which wire is what, which one holds 5 volt, which one holds earth. I don't know, and I don't care at this stage. I'm just going to quickly touch it. Do not spread these terminals, guys. I have seen multiple times on coolant temperature sensor for some reason, only coolant temperature sensor, when you have an intermittent fault, most of the time I found these terminals are spread it. Okay, someone spread that terminal and now it's not making a good contact on the sensor pin. So just don't spread that. I'm just going to quickly touch it there. I got 0.14, more than likely that's our earth. All right, there's a 5 volt right there on that pin. So that pin is my red wire. There's a red and a brown color wire right there. So I've already identified my 5 volt circuit without even going further, without even looking into the wiring diagram. Now, on the other pin, what I'm going to see? Earth, right? So now, sometimes the multimeter can lie. See, right now I'm not touching anything and it's showing me 0.1, 0.001 volt and all that. But if I put there, even if there's a earth, it's still going to show me numbers around 0 volt. Okay, you can tell, like if you got experience, you can tell by that decimal voltage readings if there's earth or not. But most of the time you don't know. If I put my lead there, is it a 0 volt, or is it a earth, or is it nothing? We don't know. That's why it's best to practice test light in that sense. Or you can always put 2 multimeter leads on this 2 wire, and if you see 5 volt on the multimeter, like 2 pins in there, you know there's earth and the 5 volt present. But for this test, I'm just going to use a test light. All right, so I'm going to go to the battery positive this time because we're looking for earth. All right, so I'm going to go to battery positive here. And I'm gonna go on this pin because we already verified that red wire is my 5 volt. Now touch that pin. My test light lights up. Hope you guys can see that. My test light lights up. I got the earth here. I got 5 volt and I got earth coming in here. Now if you got a fault code like that, voltage input high, that usually means it's an open circuit, right? What does that tell you now after that 2 tests we did? More than likely the problem is the sensor, guys. Nothing wrong with the wiring, nothing wrong with the computer. You're done. Your test is done. Put a coolant temperature sensor. That's it. Finish. Right? Now, if you didn't see a 5 volt or the earth, now you're going to have to chase the wiring up towards the computer. You're going to need a wiring diagram or service information. Okay? Now, let's say you got a short. Okay, let's say you got a short here, right? So what I'm gonna do, all right, I'm gonna short these 2 terminals. This is just a jumper lead, guys, nothing but a jumper lead. I'm gonna short these 2 pin. I'm just barely touching that pin, guys, just to show you. I'm not spreading that terminals, promise you. All right. I short that wire, okay? I'll just put that there for now. I short that wire. Now let's go and see on the scan tool what faults we get. And I'll let you guys guess what fault codes we're going to have. We're going to have a low voltage fault code, right? So let's read that fault code again. Circuit input high. We may have to clear this fault quickly, guys, first. Okay, I'll erase that fault code. and I may have to turn the ignition on and off. Okay, now I don't need to turn the ignition on and off. It straight away gave me the fault code. The circuit input is low. So what does that mean? Is computer is reading what? Let's go to the live data. All right, let's go to the live data. For this engine, 140 degree is the 0 volt, okay? I showed you on the diagram before 280. I think that's a Fahrenheit reading, but I told you I wasn't too sure about that number, but 140 degree, okay? That's the maximum number probably, okay? For this car, or maybe that could be universally true. You can try it out on different cars next time, guys, and you'll know what's the 0 volt. But we know if this scan tool had a voltage reading, you'll know it's a 0 volt. You'll see a 0 volt on the scan tool because it's shorted to ground, right? Now on the board here, I'll show you quickly. So what does that mean is this is shorted to ground means the short could be inside. Okay, something wrong here. The short could be inside the sensor. It could be shorted here. What's going to happen if it's shorted to ground right here? It's going to pull all that 5 volt to what? 0 volt. You're going to see 0 volt on the sensing circuit. Input low, right? That's the fault code description. You could have a short between the 2 wire in the wiring harness, right? You could have a separate short. This 5 volt is shorted, touching the body of the ground or the engine somewhere, a bracket, yeah? The wire is stripped and it's touching the ground. You could have a problem inside the computer, okay? You could have a problem in that circuits. You know, it's touching ground, it's sorted to ground. What are the cases? So basically what does that mean is you are reading 0 volt in that sensing circuit. Now, let's say, give you a scenario. Let's say the short is inside the sensor. There's a short, there's a problem in the sensor. Okay, we don't know that. Okay, now let's go back to my setup here. Now, is it fair to say the way I have it here, the short, I have it on the sensor here, right? Guys, I'm trying not to damage that terminals. Okay, I hope I'm still shorted. Okay, now. If the sensor is bad, when this plug is plugged into the sensor, if the sensor has a short inside, isn't that means the same thing like I'm giving a jumper here? Isn't it the same thing? Now on the scan tool, what do? You can watch the live data. It's sitting at 140 degrees Celsius at the moment. As soon as you unplug the connector from the sensor, in this case, let's unplug that. I'll unplug that sensor. Look what my coolant temperature just did. Went to minus 40 degrees Celsius. Now it's a voltage high. So the 0 volt that we were seeing on the scan tool on the sensing circuit jumped to 5 volt as soon as I disconnect the sensor. In this case, as soon as you disconnect this connector, voltage jump to high, means everything else is good other than the sensor. Put a sensor, you're done. The wiring is good, computer is good, put a sensor. So I'll just explain to you that on the board as well. So let's say we have a short inside the sensor here, right? As soon as I disconnect that, I isolated that sensor, that circuit from the sensor. Now, before it was reading 0 volt. As soon as I disconnect that, what's going to happen? This is going to jump to 5 volt because there's no path to ground now. Do you understand? So what does tell you? That tells you there's nothing wrong with this 5 volt circuit. More than likely, you could have 2 problems. Yes, sometimes it's possible, but more than likely, no. Usually you're going to have 1 problem at a time when it comes to automotive. Like, that's my experience. I'm not saying I'm 100% true all the time. No, there could be times where car has multiple problems, but most of the time, 1 problem at a time. That's how I've seen. So if you got a sensor problem, you're not going to have a wiring and ECU problem as well. Okay. Now, there are scenarios where it's possible when the sensor go bad, that can damage the computer. very, very true, right? But more than likely, and knowing that a lot of the new cars has the protection in the computer to save the computer when that sort of things happen, like if your actuator sensors are sorted, they do have a protection circuit. That's why more than likely damaged sensors might not gonna damage the computer, okay? More than likely. It depends. It depends on the circuit you're testing too. All right, but even if that's the case, as soon as you disconnect the wire, scan tool voltage jump to 5 volt, high voltage, right? You can do a quick test like we just did. Check for 5 volts, check for earth. If the 5 volt and earth is there, right? As soon as you unplug that and the voltage jump to 5 volt, nothing wrong that side. Nothing is wrong there, wiring or computer. The problem is your sensor. Change the sensor, you're done. Now, other tests you can do here is, right, while you're watching the coolant temperature data, I'm gonna set up my resistor box here, right? As you guys can see, I got 2 leads coming out of there, red and a black one. Okay, and basically I'm gonna do a bypass. I've already showed you on the board, I'm just gonna show you quickly here. Okay, for this one I might just back probe this so the wire will stay there intact. Okay, now have a look on the scan tool. As soon as I bridge that 2 with the resistor, right? Basically my 2 leads from the resistor box here, it went to 12 degrees Celsius. Now let's increase the voltage, okay? Let's increase the resistor, sorry, here, okay? I don't know how many resistor gonna change how much voltage, I don't know, I'm just gonna play with it here, okay? Look at that. I can change that voltage, temperature any day I like to anything. If I go backwards, if I turn the dial backwards, you know, or forward, you can see the changes there, guys. 51 degree, okay, 56, 61, 67. I can change that all day. So you can use this bypass test to see if the computer reacts to the changes. That way you are 100% sure. It's not necessary all the time, but if you want to be 100% sure there's nothing wrong with the wiring and the computer, you can always do this type of test to see computer reaction. And also, like I said on the board, you can sometimes use this for your benefits when it comes to diagnosing cars at instance, like I gave you example on that Mazda Tribute earlier. Okay guys, well that's that for it. We are pretty much done with the coolant temperature sensor. I'm just going to plug it back in. Now, another sensor I can quickly show you here is your air temperature sensor. All right, let's do that, air temperature sensor. All right guys, we got air temperature sensor. Now, this is in-house with my mass airflow sensor as well. So you're gonna have 1, 2, 3, 4, 5 wires here. Now you can play around with it and figure out which one is for temperature circuit and which one is for mass airflow circuit. But if you got a wiring diagram, that's even better. Okay guys, so just so we won't waste time here, I just wanted to show you that it's exactly same no matter what temperature sensor you're checking on the car. It's exactly same, there's no difference. That's all I'm trying to get at, guys. Okay, all right, so for that one I'll just go to my computer here and I just want to open my wiring diagram information. All right, it's a Toyota, it's a Hilux 2005 to 15, right? Let's go down here for wiring diagram. Hopefully it'll show me. It's a 3-liter, 2005 to 2006. And I'm gonna go to the engine electronics. Engine management wiring diagram, right? DPF with EGR. I'll just go there. I'm not too worried about the EGR and the DPF and all that here. All right, guys. Now let's find that mass airflow sensor here. Okay. Sometimes you can just look at it and you can tell. Sometimes you're gonna have to do a search. Okay, for this one I'll probably do a search quickly, just I won't waste my time. All right, mass airflow sensor here, right here, all right, right there. All right, that's your mass airflow sensor, right? I lost it. Yeah, that's your mass airflow sensor there. All right, so on this one you see we got 5 wires, right? I'm looking right here, guys. You got 5 wires. 1, 2, 3. 3 wires goes to the computer. Okay. 1 is a shared ground as well, looks like, and 1 black wire goes to the multiple source and goes to the fuse up here, fuse 23. So that's our power supply 12 volt for mass airflow sensor, the black one, we know that. The earth is a ground, it's a shared ground, and there's 1, 2, 3 other circuits. Okay, so it's a little bit hard to say just by looking at it here. We can play around with the wires and then we can figure it out exactly which wire is a what, but just to make it a little bit easy, let me just go and see if I can find a computer pin out diagram. Sometimes that helps. Control module pin data. Let's see if there's anything I can see. Alright, so I'm looking for intake air temperature sensor. Let's go down here. Intake instrumental. Alright, intake air temperature sensor right here, this one and that one. Oops, I don't know what I clicked there. Intake air temperature sensor, if you see right here, guys, so it's showing me M28 is 0 volt and M31 possibly is my 5 volt wire. Okay, so remember that M28 and M31. M28 is earth and M31. Okay, M28 and M31. M28 and M31. Let's go back to the wiring diagram. M28 and M31. Okay, let's find that mass airflow sensor. I'm pretty sure that was our mass airflow sensor, right? So M28 and M31. And there is no such thing as M28 and M31 here. See, this is a problem in Australia. We can never find a proper wiring diagram, okay? Let me try the one without the EGR cooler. Oh, that does look a bit different. Maybe they do have a different wiring diagram for different with the EGR and without EGR. Okay, mass airflow sensor M28 and M31. Okay, so the M28 right here, guys, if you see, I'll zoom that right in a little bit more. So that's my mass airflow sensor right here, B30, and M28 and M31. So M28 is my brown wire, M31 is my yellow with the black wire. So let's find that wire here. So brown is a shared ground, right? I think it shares ground with black is my power for the mass airflow sensor. Brown is a shared ground. I got two other wires here, red and black and white. I would say that's for your mass airflow sensor. So this yellow one with the black, so this far end, okay, if I were to do this diagnostic, I would probably just start checking, and I'll probably figure it out which one's my there's ways you can figure it out which ones when you have a multiple wires in one sensor, multiple circuits in one sensor, you can always verify that without a wiring diagram. But just to make it easier, I just wanted you guys to sort of walk you through how else we can do it here with the help of the wiring diagram. So the brown and the yellow, okay, we found that's our sensor wiring. Now let's go back to my scan tool data. Now I'm interested in intake air temperature sensor, okay? All right, intake air temperature sensor is sitting at 31 degrees Celsius at the moment, okay? Now, as soon as I disconnected this, it's the same exact principle, guys. Went to minus 40. Exactly same thing we did on the coolant temperature sensor. Now, if you look at the fault code, I'll show you that anyway, so you guys can get used to it. So I'll just read the fault code. I'm not worried about the coolant temperature fault there, but let's see what other fault codes come here. All right, right here, forget the coolant temperature fault code. Just we're gonna have a mass airflow sensor because they are together, right? So don't worry about that mass airflow either. I'm just worried about the intake air temperature circuit high. Okay, right there you can see intake air temperature circuit high. It's the same exact same thing, circuit high description, because computer is seeing 5 volt on the sensing circuit at the moment, right? So if you go back to live data, minus 40. Now we already verified this 2 wire. I'm gonna short this wire, okay? Or we can always use a resistor and change that value, right? But I can short this, and it's going to give us the circuit low fault code now if I short this. So I'm just going to go back probe that yellow wire and that brown wire for the intake air temperature, guys. Right, as soon as I short it, look at my scan tool, went to 140 degrees Celsius, exactly same thing, right? If you go to trouble codes, I'm just going to erase that extra fault code and I'll read it again. All right, guys. See, we're going to have a mass airflow sensor circuit, low, all circuit low faults here. Intake air temperature low circuit. Before it was high circuit because we was seeing 5 volt at the sensing circuit. Now the sensing circuit is reading what? 0 volt. That's why it's a low circuit fault. Now, like I just demonstrated, they're all same, exactly. Just treat all temperature sensor exactly the same, because this has mass airflow sensor together, so you might get a little bit confused. Oh, how do I check it? Just isolate 2 circuits, they're different sensor, 2 different sensors in one housing. That's all. Okay, that's that. All right. If you check the voltage and earth here, you're gonna see exactly like the other sensor we did, coolant temperature sensor. You're gonna see 5 volt, and you're gonna see earth. Exactly same principle. There's no difference. Okay. Now, okay, I gotta put my multimeter right here. Multimeter connected to battery negative. Okay, I'm just going to use my AC pipe there. It's a negative anyway. Now, yellow and brown, right? I'm going to go to yellow wire. What do you see? 5 volt. Move that lead out of the way for you. 5 volt, right? Right there, 5 volt. What's the other gun going to have? Other one's going to have earth supply, right? So here's my test light, right? I'm going to touch that brown wire. What do I see? My test light's connected to battery positive. I see earth right there. Now, when you don't have a wiring diagram, as soon as you unplug it, let's say this is a coolant temperature sensor, you don't know which wire is what, just put your test light, multimeter, you know already which one's a 5-volt circuit, wire, and which one's earth. Okay, that's pretty simple. All right, guys, saying that, just treat any temperature sensor like this. Anything, doesn't matter what it is reading. Doesn't matter if it's reading oil temperature, it doesn't matter if it's reading coolant temperature, fuel temperature, air temperature, cabin temperature, outside air temperature, doesn't matter, it's all the same. All right, guys, I'm gonna wrap it up. Hope you enjoyed that coolant temperature sensor video. I'll see you guys next time.